Hi, my name is Newell Kitchen, and I appreciate the opportunity to share some thoughts with you on this topic of the crop management and it matters to soil productivity. Um, and kind of a subtitle, what is an inch of topsoil worth? So to begin with, I'd like to share one of my favorite graphs that I've used or figures that I've used over the years. And this is a figure of some research work that kind of launched some of our early precision agricultural research up in the Centralia area, a field that we've been on for over about 30 years now. And from that, we were able to, with some soil sensing work, be able to identify what the current depth to the clay pan in inches was for that field. That's the middle figure there. From other work and some other uh, associations, we were able to kind of be able to generate what we thought that field looked like in 1800s prior to any kind of agriculture. And as you can see, there is a tremendous amount of erosion that's taken place. And in fact, it's an average of 7 inches of topsoil on this field. The third figure shows how much of that topsoil, and that it's not evenly done. Eroded. There are some places where there's been 12 inches of erosion, other places much less, and some places, a few small places, even some deposition. But the key here is there's been a lot of erosion, and this is not unlike many fields in Missouri, some of the poorly drained soils like the clay pan soils. And so erosion is, it's happened, and it frankly, unfortunately, continues to happen to a lesser extent perhaps, but still happening even on no-till. And our research work has shown that that rate of erosion is even more than the rate of soil formation. So we're still haven't really stopped the bleeding when it comes to erosion and the impact that it can have. So what do we do? What now? So first you have to identify why it's such a problem. Well, there's on these poorly drained soils, there is traits of these soils that just make it difficult to grow crops. And the more you lose topsoil from erosion, the more difficult that's going to be. So you have prolonged saturation during wet conditions, and you have a lack of available water for plants during dry conditions. And these factors really become exaggerated as you lose that topsoil and expose the clay pan near the soil surface. So we need to know how and when it affects yields, this negative effect of erosion, and we need to know what management practices or strategies we can do to reduce the impact of that eroded soils, and what things can we do. So how do you study soil erosion, or the impact of erosion on soil productivity? Because this is more typical to what a clay pan soil landscape looks like, where you have a great deal of erosion that's taken place on the side slope, where you have some slope and where tillage has resulted in that soil being loosened up and then being moved down slope, where you can have some areas of accumulation of topsoil, where all the way to a summit position where there's less erosion but still some erosion. And so you have this variation across the landscape. How do you study that? How do you take that and you evaluate that from the standpoint of traditional kind of agricultural research, and try to look at what effect that can have? And there's several different ways you could do that, some things that we've done on a field scale. But one of the things that was done, and actually started back in the 1980s here in Missouri and South Farm, was an area where a number of individuals created what they called the erase plots, where they took areas and they stripped off topsoil on some and accumulated it on others. And so this is one of an early photo of that research area, and back in the early 1980s, where you have continuous soybean and continuous corn and the impact of fertility and with and without irrigation, with that factor of topsoil depth varying across these plots. Well, that work took place for about a decade, and then those plots were abandoned. And then about 2009, we came in and we restored those plots, or resurrected those plots back into a research mode after having been out of production for about 15 years. And and we now call that the Soil Productivity Assessment for Renewable Energy and Conservation, or SPARC is our acronym for these plots today. And so there's some specific questions we've asked relative to this topsoil depth or the extent of erosion on productivity. And that's what I want to share with you today is really what impact is that? And that subtitle, what is the value of an inch of soil? And maybe answering that question helps individuals realize why it's important to stop or really minimize erosion for future production on soils here in Missouri, or like soils here in Missouri. So this research is really, I'm going to be sharing some work that Lance Conway was a graduate student that worked with us on his master's degree on these plots. And I'm going to share some of the results that he came up with using these plots to help answer that question. So it's really worked from 2009 to 2015. There's a bunch of information related to the economics and the that go into that, and that's detailed in published work. So I'm not going to go into that here. During that 7 years, we had both kind of wet years and some dry years, 4 wet years and 3 dry years that kind of help us to look at how climate or how weather can impact productivity. And then looked at the yield and relative yield, the net return for both the wet and the dry and across all years. So let's take a look at some of the data, and there's the thing to focus on are the lines here, not necessarily all the dots. There's a lot of dots on there, and that kind of makes it more confusing. But we have on these graphs, we have along the x-axis, we're looking at the depth to the clay pan. So this is how much topsoil is left, and then on the other is looking at relative yield. And so we're looking at those 3 different crops of corn, soybean, and switchgrass, and you can see that really all crops were affected to some extent by the depth to clay pan. When you look at it though, switchgrass had the greatest and the most stable relative yield at shallow topsoil or depth to clay pan. So, which is kind of what you would expect because it's a perennial, it's rooted and deep, and those same root systems are kind of going from year to year. And so there's perhaps some things going on relative to capturing water early in the spring and using that water with switchgrass that you're not going to get with a grain crop like soybean or corn. If we now look at net return to that, relative to that depth to clay pan, we can see on wet years, so these are just the wet years, that switchgrass was pretty stable, but also just barely above 0, or just barely above just a little bit of profit, and that's it. Soybeans similarly, but flat, but with considerable profit on a dollars per acre basis. But corn on wet years are the ones that really see a relationship with that depth to clay pan. And the reason for that primarily on wet years is because without topsoil, you have a soil that's much more vulnerable, much more susceptible to denitrification, and you get nitrogen loss. And so if you're putting it on 180 or 200 pounds of nitrogen, it's really easy on a wet year to lose that nitrogen. And so you're going to have a loss in yield and a loss in return because of that lost nitrogen on that type of a soil. Switchgrass, as I mentioned, unable to compete with the grain in profitability, so it's pretty flat. All crops were profitable. There's the profitable line, but just barely so with the switchgrass. So now let's look at the dry years. Well, we have soybean showing that it's positive, but also curved. Corn is kind of a linear relationship, but it's definitely much, much less than soybean. They're all affected by depth to clay pan. It's primarily because of lack of water, that plant available water. Switchgrass more profitable than corn on dry years across the depths of the clay pan. Again, if we throw the break-even line in there, you can see that corn is unprofitable until you reach a depth or depth to clay pan of about 10 to 12 inches. So now across all years, you can see that corn and switchgrass were affected by depth to clay pan. Soybean was the most profitable, and when you mix those wet and dry years together, it's fairly flat, and there's not really a big impact of depth to clay pan or topsoil depth with soybean. The break-even line shows, though, that all crops were fairly profitable, but just really marginally so with the switchgrass and with corn at the low depth to clay pan levels. So placing a price tag on topsoil, how do we do that? Well, you take these relationships and you really find out that an inch of topsoil is worth about $12 per acre per year when you're growing a corn crop. And that's pretty significant, $12 per acre per year, every year going into the future, because you're not going to replace that topsoil. So the maximum return was observed at 12.5 inches. Well, so then going back to the field that I started this presentation on, at 7 inches of topsoil loss, that translates into over $7,000 of unrealized profit because of the erosion that has taken place on that field. And it's going to happen every time you grow a corn crop. Well, if you're growing corn every other year, that means over a period of 20 years, that's $70,000 unrealized profit on that field as a result of topsoil loss. So over the life, and that's just one field, one 90-acre field. You spread that over all the fields that a farmer might have in his that he's farming, and it's going to result in, you know, hundreds of thousands of dollars, even up to millions of dollars over the lifetime of him being on that field. So we got to stop. We need to do a lot more to prevent erosion. And some will say, yeah, we pretty much have. Well, that's not the case, because these wet springs that we have often here in Missouri, 2, 3, 4-inch rains, when fields have been tilled, you're going to get erosion. And a few years ago, this is a photo that I took of a field where a 4-inch rainfall created gullies that followed the planter rows. Really become channels based upon that planter furrow. And there was about a 2-inch deep by 1-inch foot wide of a 30-inch row-spaced corn crop, where you can see the germinating corn with the soil, that 2 inches of soil above that seed was completely stripped off in those areas. And that's been moved down slope, in some cases moved right into streams and down larger rivers and into the Gulf. And so erosion is not something that we can just, you know, turn a blind eye to. We really need to address issues of erosion, continue to work on preventing erosion on our production fields. In this case, it was an inch of topsoil that was consumed over that whole area approximately, which it would take the 300 to 400 years of growing grass to restore that inch of soil that happened this one rainfall event. Thank you for your time. This has been a joy to be able to share some of this with you. I hope you find it interesting and as well as educational, and inspire you to be an advocate for preventing soil erosion. Thank you.